Quick blurb advocating understanding of proportionalities and so forth. I don't expect you to pick this up and become an expert from just saying it, but it's important for actually being able to think about certain relationships and certain types of experimental data. It's simply the question of how much difference would we expect between a pendulum of, say, 96 centimeters, close to this one, and 100 centimeters. How much difference would we expect in the period? Well, the difference in the lengths is 4%. This pendulum is about 4% longer. Now we could say 4.4% if we want to be more refined, but I'll just go with 4% because it's a little easier to think about. Would not be difficult to do 4.4%. You should probably consider doing that in your head. Now, we really have a 0.5 power. We got 0.499 when we analyzed our data. But that's so close to 0.5 that we're going to use 0.5. We've got the 0.5 power of the length. Now, if the length is 4% greater, it turns out that the 0.5 power, or the square root of the length, should be only 2% greater. So that if we go from a 96 centimeter to a 100 centimeter pendulum, we should have about a 2% increase in the period, because if the length increases by, if the square root of the length increases by 2%, the period, which is just a constant multiple of the square root of the length, will also have to increase by the square root, a factor equal to 2%, okay? By the same factor as the square root of the length, and that would be 2%. Now, why a 4% difference in length gives us a 2% difference in the square root of the length? Something you kind of want to pay attention to. You can do that just by squaring a binomial, but I'm not going to talk about it just right now. The 2% increase in the 1.96 second period, well, 2% of 2 is 4, so 2% of 2 is 0.04. So we'd expect about a 0.04 increase in the period, because 1.96 is really close to 2. So a 0.04 second increase in the period, which has nothing to do with this 0.04 seconds incidentally, would give us a 2-second period. But we observed a 2.03 second period, which is like 1.5% bigger than we would have expected for a handheld pendulum. So that allows us to do a quick and cursory comparison to see if we're getting anything significant. And we can do that in our head if we practice doing simple calculations in our head and making certain types of simple approximations. There are only a handful of them that are really commonly used, so you can get by with one of these approximations is simply that the square root of a number close to 1 is twice as close to 1. That's basically what I use to get the 2% from the 4% difference. Using those types of approximations, you can get in the habit of doing that and seeing this much more quickly than you could punch it into a calculator or into a spreadsheet or into a computer algebra program. You can do a quick check to see if we're getting a significant difference here, and we find that we are. So, why the 2% difference here? Well, if you don't encounter that, you're probably not in a field where you would, but I guess I'm going to do just a quick additional video on that just to show you how simple that is, and hopefully I've given you an idea why that sort of approximation is important.